Let's go through each of the terms, their units, and the factors affecting them. Potential difference. Potential difference, also known as voltage, is the difference in electric potential between 2 points in an electric circuit. It represents the work done per unit charge in moving a charge between the 2 points. The unit of potential difference is the volt, V. Factors affecting potential difference include the presence of a power source, such as a battery, the configuration of the circuit, and the resistance in the circuit. Electromotive force, EMF. Electromotive force is the energy per unit charge supplied by a source, like a battery, to drive electric current in a circuit. It represents the total energy conversion in a source. The unit of electromotive force is also the volt, V. Factors affecting EMF include the type of power source, the chemical reaction or mechanism generating the EMF, and the internal resistance of the source. Current. Current is the flow of electric charge through a conductor. It is measured in amperes, and represents the rate of flow of charge. Current can be influenced by the potential difference across the circuit and the resistance to the flow of charge. Resistance. Resistance is a measure of how much a material or component opposes the flow of electric current. It is denoted by the symbol R, and is measured in ohms, omega. Factors affecting resistance include the nature of the material, its dimensions, temperature, and the presence of impurities or defects. Conductance. Conductance is the reciprocal of resistance and represents how easily a material allows the flow of electric current. It is denoted by the symbol G, and is measured in Siemens, S. Conductance is influenced by the same factors as resistance. Charge. Charge refers to the fundamental property of matter that gives rise to electric forces. It is quantized and can be positive or negative. The unit of charge is the coulomb, C. Conventional current flow. Conventional current flow refers to the direction of flow of positive charges in an electric circuit. It assumes that positive charges move from the positive terminal of a power source to the negative terminal. This convention was established historically and is still widely used for analysis and calculations. Electron flow. Electron flow refers to the actual movement of negatively charged electrons. Electrons move from the negative terminal of a power source to the positive terminal. Electron flow is the physical flow of charge in a circuit and is opposite to the conventional current flow. In summary, potential difference, voltage, electromotive force, EMF, current, resistance, conductance, and charge are all key concepts in electricity. They are measured in units such as volts, V, amperes, A, ohms, omega, Siemens, S, and coulombs, C. Factors affecting these quantities include the presence of power sources, the configuration of the circuit, the characteristics of materials, dimensions, temperature, and the nature of the charge carriers, such as electrons or positive charges.